Hello guys, greetings to everyone and welcome to my YouTube channel, Understanding Mathematics with Pride. We will continue with the second part of topic 0. What are the branches of mathematics? It is simply a continuation of the first part. Note, if we take the first hyphen, math is really so broad. Mathematics is really so broad. Reason why it is broken into various branches to ease its learning and understanding. You can see it. Mathematics is really so big. So to ease its learning and understanding, it has to be broken down into subsections so that it can be easily understood. As for the first hyphen, math is really so broad. Reason why it is broken into various branches to ease its learning and understanding. As for the first hyphen. So next, we are going to move down to the second hyphen. Second hyphen. When we talk of the branches of maths, we are simply referring to the subdivisions of maths into different fields. We are simply referring to subdivisions of maths into different fields to facilitate its studying, so as to make the studying of mathematics very easy for learners. That's why it has to be broken down into subdivisions. That's why you have a section dealing with numbers, you have a section dealing with shapes or figures, you have a section dealing with equations, so as to ease its understanding. Let me write it down and finish this. Then we move now to the third hyphen, into different fields to facilitate to different fields to facilitate its studying. Its studying. So next we move now to the third hyphen. And this hyphen, we are going to talk of the major branches of mathematics. Mathematics has 4 major branches. Maths has 4 major branches, which are maths has 4 major branches, which are, when we talk of these major branches, we are simply referring to those branches of mathematics from which other branches or fields are derived. So the 4 major branches are, I'll write them down with a red pen because they are very important. We have quantity, structure, space, and lastly, and change. Those are the four major branches of mathematics. You can see that these words, they are almost all in the definition of mathematics we saw in the first video. For those of you who can recall the definition, you discover that almost all these four words are found in that definition. Next, let's continue. The other different branches, the other different branches, and fields are gotten from the above four major branches. Are gotten from the above four major branches. The four major branches we just listed above: quantity, structure, space, and change. So now, next, we are going to take each of the four major branches listed above and we explain it in details. That's the next thing we have to do. So if we take the first one, I, by the margin, quantity. That's the first major branch. We have quantity. When we hear the word quantity, first we think of size. That's the first thing we think of. So quantity. This is the branch of mathematics. This is the branch of mathematics that deals with numbers. So let's write down something on this. This branch deals with this branch deals with the study of numbers. Here, comma, here. Here, we study the set of numbers. It means under this branch, we study the set of numbers. That is, I will give out the set of numbers which are studied under this branch of mathematics. That is, the set of natural numbers. The set of natural numbers. I'll write down the set of numbers with a red pen because they are very important, and these are things we are going to treat in future. Set of natural numbers, set of integers, set of rational numbers. You take note of all these set of numbers I'm listing. They are very, very important. Set of natural numbers, set of integers, a set of rational numbers, set of irrational numbers, the set of real numbers, and lastly, the set of complex numbers. The set of complex numbers. So now next, we proceed to the next branch, the next major branch of mathematics, which is structure. Proceed to structure. So when we talk of structure, we simply think of the role of organization of an object. That's the first thing we think of when we hear the word structure. We saw this when we were given the definition of mathematics in the first video. So for those of you who haven't watched that video, try to watch it. So structure, many mathematical objects have an internal structure. Many of them. Many mathematical objects have an internal structure. The structural properties of these objects are investigated in the study of, I will give out some topics in mathematics or some fields in mathematics where we study structure. The structural properties of these objects are investigated in the study of number theory. I'll write them down with a red pen. Number theory, let me finish with this one before I write them down. In the study of, let me use my red pen. Number theory, comma, abstract algebra, abstract algebra, after abstract algebra we have group theory, group theory, group theory. Let me write this down. Group theory. And order theory, order theory. Full stop. So it does not mean these are the only fields where we study structure. There are many others. So you can do your personal research on the others. So next we move now to 3I, space. Space. That's the third major branch of mathematics, space. Most often when we hear of space, we simply think of an empty place. Space. So let me write this down. When we hear of space, 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 we think of an empty place. Think of an empty place. We think of an empty place. A place where there's nothing. I'll underline the word empty place. That word means a lot. So now let's define space mathematically. A space is simply a set of points. A space is simply a set of points. When we talk of a set of points, that means a collection of points. each of which each of which each of which each of which is uniquely each of which specified is uniquely specified by a number of coordinates by a number of coordinates. I'll use my red pen to underline the word number of coordinates. So you take note of that. It's very, very important. Next, let's continue. The study of space originates with the study of geometry. So that's where the studying of space originated. Precisely Euclidean geometry. Let's write it down. The study of space originates with the study of geometry. Originates with the study of geometry. You can enjoy the birds singing. I'm in a natural environment. Very calm. Such places are very good for the studying of mathematics. Precisely Euclidean geometry. Full stop. So that's where the studying of space started from. Next, we study space in the following. We study space in the following. Study space in the following. I'll write them down with a red pen. We study space in the following. Geometry, you know that's the mother of space. Geometry, trigonometry, differential geometry, for those of you who continue with mathematics at higher levels, you will enjoy most of this. You will enjoy them so much. For differential geometry. Next, topology. In topology, we study space and measure theory too. Yes, measure theory. We study space. Measure theory. Study space. So stop. Even in vectors too. In vectors too, we study space. So next, let's go to IV, which is for the fourth major branch of mathematics, which is change. Change. We are so versed with the word change. So when we talk of change, it is simply the process of becoming different. So now let's write this down. In real life, many problems arise from relationships between a quantity and its rate of change. You can see we are making use of that word change again. In real life, many problems arise from the relationships between a quantity and its rate of change. Quantity and its rate of change. Okay, so I underline the word quantity and its rate of change. You can take a very simple example. For example, water flowing out from a tap. That's an example of a real life problem involving a particular quantity and its rate of change. So next, let's continue. Change is simply the process of becoming different. Change is simply the process of becoming different. We study change. I'll continue from there. Becoming different. We study change in calculus. Study change in calculus. Vector calculus. Vector calculus. Differential equations. In bracket DE. We denote differential equations by using capital letter D and capital letter E. That's how we denote it. And in complex analysis too, we study change. Complex analysis and complex analysis. So next, we will move now to the fourth hyphen. So in the fourth hyphen, we are going to talk of the main branches of maths. So when we talk of the main branches, we are simply referring to where most of the topics in mathematics arise from. Those are the main branches. So the main branches of maths are I'll write them down with a red pen because they are very important. The first one, we have foundation and philosophy. When we talk of foundation and philosophy, we are simply referring to where we treat mathematical reasoning and logic. Then the next one, we have arithmetic. When we hear arithmetic, we think of operations on numbers. Then next we have algebra. When we talk of algebra, we are simply referring to the replacement of numbers with letters and the rules of manipulating the letters. Then next we have geometry. When we talk of geometry, we are simply referring to space, the studying of space. Then next we have trigonometry. When we talk of trigonometry, we are simply referring to that branch of mathematics that deals with the relationship of the sides and angles of a right angled triangle using trigonometric ratios. Then next we have calculus. When we talk of calculus, the manipulating of symbolic expressions using fixed rules. Then we have probability and statistics. When we talk of probability, we think of the likelihood or the chances of something occurring. Then next, when we talk of statistics, we have collection, presentation, analysis, and interpretation of data. Then lastly, we have number theory. When we talk of number theory, it is simply concerned with the properties of integers. So next, we move now to the feed hyphen. Feed hyphen. The branches are further broken down. The branches are further broken down into fields to ease specialization. The branches are further broken down into fields to ease specialization, especially at higher levels of studies, especially at university levels. So next, let's define a field. I know most of you will be confused. What is a field? A field is a domain of study. A field is a domain of study, knowledge, or practice. A field is domain of study, knowledge, or practice. Let me write it down. It's very important. Take note of it. It's a domain of study, knowledge, or practice. To solve particular problems. So you take note, a field is a subsection of a branch. So when a branch is broken into subsections, we have fields. So you take note of that. I'll underline the definition of a field. It is very, very important. So you take note of it. Then next, we are going to list some examples of fields in mathematics. So some examples of fields in maths are, I'll list them down using a red pen because they are very, very important. Some examples of fields in maths are, first, we have financial maths. When you hear financial maths, you think of business. That's mathematics in business. Then next, we have mathematical economics. Mathematical economics. Think of maths in the subject economics. Then next, the next one, we have a probability theory. Let me write down mathematical economics first before I go to the next one. Mathematical economics. Next one, we have probability theory. Probability theory. Here we treat the likelihood of things happening. The next, statistics, data collection, presentation, and analysis. Analysis of data. Then the next one, we have optimization. When we talk about optimization, it's simply finding the best solution of a real life problem, having constraints. Then the next one, we have analysis. When we talk of analysis, it is simply the mathematical study of functions, sequences, series, limits, derivatives, and integrals. Then we move to the next one, mathematical physics. That is mathematics in physics, like in mechanics, waves. There's so much application of maths there. Then we have mathematical biology. That is mathematics in biology. We make good use of probability and statistics in biology, like in fields like genetics. Then the next one we have game theory. In terms of game theory, you can think of games. Most games are built on maths, on mathematical theories. If you think, for example, games like checkers and chess, they are built from mathematical theories. Then we have many others. There are many others. There are many other fields. So I'll just write down and many others. You can do your personal research on them. At university levels, interrelated fields are compiled to form options under the maths department. For example, applied maths, pure maths, math and statistics, maths and computer science. Thank you very much for watching.